Hi, this time I'm looking at the Double Award Science Chemistry component. It's Unit 7 Practical Skills and it's Booklet B, and this time it's the higher tiers paper. So that is 7B or 3B, higher tier. It's a 30-minute paper that you do about 15 minutes after you complete your Unit 2 paper, so they're done on the same day. So question 1, hydrated nickel 2 sulfate NiSO4.xH2O was placed in an evaporating basin and heated to constant mass. Explain what's meant by the term heated to constant mass. So they're looking for two things: heat it and weigh it, and then until the mass doesn't change. 2 points there for those. And the following mass measurements were obtained during the experiment. So the mass of the evaporating basin, 45.12, the basin and the hydrated nickel sulfate, 50.38, and the basin and contents after heating, so 48.22 when it's heated to constant mass. So then calculate the mass of hydrated nickel sulfate used in the experiment. So we're taking the mass of hydrated nickel sulfate and the evaporating basin, which is 50.38, take away the mass of the evaporating basin, which is 45.12, and that gives us 5.26, so 5.26 grams. Then calculate the mass of water lost from the compound. So 50.38 was the mass of the basin and the hydrated sulfate, and then 48.22 was the mass of the basin and the contents after heating to constant mass, and that gives us 2.16 grams as the difference. Apologies if you hear strange noise in the background. My dog has decided to drink about a litre of water. Hence deduce the mass of the anhydrous nickel 2 sulfate. So we've got 5.26 grams is the mass of the hydrated nickel sulfate. So the anhydrous nickel sulfate is that 5.26. Take away the mass of the water which was lost, which is 2.16, which gives us 3.10 grams. A student carries out a similar experiment to find the formula of hydrated magnesium sulfate MgSO4.xH2O. The results are shown below along with the beginning of the calculations. I'm not sure why they've changed from nickel sulfate to magnesium sulfate here. Who knows? Hopefully in a real exam they would just carry on with the results they'd already given you, because I think that causes a bit of confusion here. It's unnecessary. Anyway, so magnesium sulfate, the mass was 3.09 grams. And then you have to work out the formula mass, which is 120. Then the number of moles, I've just written in here, number of moles is mass divided by the formula mass. So that's 3.09 divided by 120, which is 0.026. I'm going to just look at the water next. So they've given you 3.24 grams of water. The formula mass is 18. So the number of moles of water is 3.24 divided by 18, which is 0.018. Then we need the mole ratio, and I've written in here you divide by the smallest. So take the smallest number, which in this case is 0.026. So when you divide 0.026 by 0.026 you get 1, and 0.018 divided by 0.026 gives 7. So the ratio here is 1 to 7. Now, this is just asking you to calculate the formula mass, use the mass and the number of moles to calculate the moles of each sample, fill in the gaps in the table, calculate the mole ratio. So I've done that there. And then what is the formula of the hydrated magnesium sulfate? We've got 1 to 7 ratio, so MgSO4.7H2O. And it says anhydrous copper sulfate can be used to test for water. State the colour change that would be obtained going from white to blue. Now, number 2, sodium thiosulfate solution Na2S2O3 reacts with dilute hydrochloric acid according to the equation. So we've got the equation here, Na2SO4 plus 2HCl gives you 2NaCl plus S, which is solid, SO2 is a gas, and H2O, which is liquid. Diagram shows the apparatus used to investigate the effect of changing concentration of sodium thiosulfate on the rate of this reaction. So you see the white paper, you're very familiar with this experiment, with a cross, and the reactants in the flask. So precipitate is produced, which causes the solution to become cloudy. The rate of this reaction can be investigated by timing how long it takes for the cross drawn on the white paper to disappear from view. So which product causes the solution to become cloudy? So looking here, the only thing which is a solid in that equation is sulfur. and the S isn't for solid there, it's the symbol for sulfur, obviously. Then we've got a series of experiments carried out to investigate the effect of concentration on the rate of reaction, which produced these results. So we've got different concentrations of the thiosulfate, the times taken for the cross to disappear, and then the rate of reaction, which is calculated as 1 over time. And there's a gap here. You'll see I filled it in. We'll come back to that in a minute. State 2 precautions which should be taken to ensure a fair test. So there's quite a list here on the mark scheme that they gave. I would have said the two most obvious ones would be the same temperature, the same total volume. You could also have said the same cross, the same conical flask, I suppose in case the bottom of one flask is thicker than the other or something like that. Same concentration of the hydrochloric acid, the same volume of the hydrochloric acid, and the same volume of sodium thiosulfate. So any two of those were acceptable from the mark scheme. So calculate the rate of reaction for experiment 4 and insert the value into the results table on the previous page. So if we look at that, and it is here, so the time was 32. And if I go back to my working out, rate is 1 divided by the time. So 1 divided by 32 is 0.03125. And you'll see that that's what I've written in here in the table. So from the results of the experiment, state the effect of increasing concentration of sodium thiosulfate on the rate of reaction. So back to the results table. So as you can see, increasing the concentration is going from the top to the bottom. And what that does is it increases the rate. So just writing in one word, increases. Name 2 other factors apart from concentration of sodium thiosulfate that will affect the rate of this reaction. So you could have temperature, you could have the volume of hydrochloric acid or the sodium thiosulfate, the concentration of the hydrochloric acid. Now it says very specifically in the mark scheme, do not accept catalyst or any reference to surface area. So they're not going to give you any marks for those. So stay away from them, just stick to what you know from the experiment. So any two of those would have given you your 2 marks. Now, a student is given 3 gas jars labelled A, B and C and told that one contains nitrogen, one contains carbon dioxide and one contains oxygen. The student does not know which gas jar contains which gas. So give 2 similarities between the 3 gases and describe how, using tests for gases, you would work out which jar contains the nitrogen. Additional jars containing A, B and C are available as needed. It's one of these quality of written communication answers, so you need to make sure that you're writing in a logical, sequential fashion with use of specialist scientific terms. So similarities, and you get a maximum of 2 indicative points for these. They're colourless, they're odourless, they're all non-toxic, they're all tasteless, they're all found in air, so any 2 there. And then for the testing. So the idea of testing in a logical order, like taking a jar, not the gas jar, and test all 3. Then using a glowing splint would relight. Now, they did this in the foundation tier as well. It's the same in the mark scheme. They also said you could use a lit splint, which burns more brightly. And those are both tests for oxygen. I would say please stick to oxygen relights a glowing splint. Yes, it does make a lit splint burn more brightly, but the more accepted test is the glowing splint relights. But 1 mark for each of those. Then adding lime water, which turns milky with carbon dioxide. And then finally that nitrogen is identified by elimination. So if you had 7 to 8 points, indicative points there, you've got 6 marks. 4 to 6 was 4 marks. And between 1 and 3 is 2 marks. Now I have 2 unlabelled powders believed to be copper 2 chloride and lithium chloride, which have been left in a laboratory. A student carries out a flame test using a sample of each powder. Outline the procedure for cleaning the nichrome wire and include the name of the acid used. So for cleaning the wire, you're dipping the wire, that's 1 mark, in concentrated hydrochloric acid, so that's the name of the acid. And then you're holding the wire in the flame until no colour is produced, or you could say until the wire is clean. Then the colours observed in each sample, so copper chloride is going to give us the blue-green. You could also say green-blue, but remember no slashes in there, they don't like that. And lithium chloride gives you the crimson colour. Final question. Sodium and potassium are group 1 metals which react with water. Describe 2 similarities between the reactions. So any two of these, the metal moves about the surface, the metal disappears, heat's given out, there's a vigorous reaction, or bubbles or fizzes vigorously, and a gas is given off. Now the final one on the mark scheme here I don't really like, because CCEA contradict themselves in their fact files, their e-guides, and so on. And the Royal Society of Chemistry website say that sodium does not catch fire, but lithium does. I would agree with them. For me, the sodium will only burn if it gets stuck at the side, in which case it will spark, but it doesn't catch fire. The only way it will do that is if you set it on a piece of filter paper, which is not what's being asked here. So I would steer away from saying they both catch fire. Now, again, the mark scheme for this, I feel, is not well conceived. So we have sodium, they're saying a yellow flame, potassium a lilac flame. What I would have said would be that sodium does not produce a flame, potassium burns with a lilac flame. And then the other bit, and they did this in the foundation tier as well, I've already had a rant about this there, but again it's contradictory in the CCEA e-guide, their fact files, and then with my gold standards, the Royal Society of Chemistry. So they're saying that sodium turns into a ball and potassium doesn't turn into a ball, whereas the Royal Society of Chemistry state that potassium melts as it reacts. I think this question has been ill-conceived, and I hope that if they give something like it in future, they give more credence to the fact. Here, for me, the main difference would be that the potassium is a more vigorous reaction. And come on, let me write an S. So it's a more vigorous reaction, and that it burns with a lilac flame, where sodium is less vigorous and doesn't burn with a yellow flame, but it does, if you want to say it can spark if it gets stuck at the side. Okay, that's the end of the higher tier practical B paper. Thank you for watching.